Okay, folks, so we've been doing a little bit of work on the properties of these logarithms. So we've expanded them, we've condensed them, we've evaluated them, and in these next two lessons, we're going to put them all together to solve some equations. So the first step we need to solve these is just to learn how to rewrite them. So that's what we're going to focus on here. And we're going to use the fact that I introduced at the beginning of this series of lessons about logarithms to do that. So that fact is this. Okay, so the fact is that logs and exponents are inverse operations of each other. They're opposites. And what I've highlighted here is the thing you really, really want to get down in your notes. So log base b of a equals c is the same statement, same equation as b to the c equals a. So we're going to use what I've highlighted to rewrite these. We'll see what we mean when we tackle this first one here. So here, log base 8, so that's my b, right, of a. So a is 4x in this case, follow my model, equals c. And then I'm going to rewrite it in this form, so the right-hand form. So this is the same as saying 8 to the third equals 4x. Okay, so notice now it looks like an equation that I might be able to solve. So we're not going to solve these in this lesson, but you could do a to the third power on your calculator and then divide by 4 and you'd be done, right? So that's all we're doing here is just rewriting them following this model. And even if they look scarier like our next one, we're going to do the exact same thing. Okay, so in this one, x plus 3 is my base. 2 is my exponent, so I'm following the same pattern as we did up here. I'm going to put parentheses around my base this time to say I'm squaring the whole thing. Equals x plus 6. Okay, and then let's do some little highlighting here to make this a little more clear. So x plus 3 is the base. That becomes the base over here. And then 2 is my exponent. That's my exponent up here. And then x plus 6 is what's left over. That goes on the other side. So again, that's all we're doing is rewriting these. But we could solve this equation, right? So this is a quadratic equation, so you could solve this by squaring this side, moving everything over so it's equal to 0, and then either factoring a quadratic formula. But you don't need to do that. You do not need to solve for x. Okay. This is a good time to pause. Make sure you have what I've highlighted up here captured in your notes, and you have these two examples captured. I think this lesson will go pretty quick, but like doing this lesson really well will make you prepared for the next lesson going forward. And then before we move on, we'll tackle this scary looking one. So we have my base is x plus 2. My exponent is what's on the right here, so 3x minus 2. I'll put everything in parentheses this time. Equals what's inside the log, so x squared minus 2x minus 16. So that's a scary looking one, but notice we followed the same pattern, so I don't care how scary all these expressions are. It's the same pattern as this one. Okay, so make sure you understand how I got that before we move on. And then we'll do one more. This one, notice what's changed here. We have an ln. So natural log this is. So remember, this just means we can rewrite this as log base e. So that's just what natural log is defined as. So if I rewrite it that way, it becomes the same type of problem as all the rest of them. So that's just a fact you need to know, that ln natural log means log base e. And one of our goals for this unit is to become comfortable with that number e. And then I just rewrite it just like the rest of them. So my base is e, my exponent is 3/5, so e to the 3/5 equals 3x plus 2. Okay, so same thing. Okay, go back and rewind if you're not feeling confident, but if you're feeling confident, go ahead and jump into these problems.